I guess I'm going to do a series of videos. This first one will be on absolute value, and I'm going to cover everything that I hope you learn by the end of the semester. Thus far, we've been only graphing, sketching absolute value. I guess I'll start there. Something you know. Absolute value V-shaped graphs. They're either like quadratics, decreasing then increasing, or increasing then decreasing. This has a positive multiplier. This has a negative. Okay, nothing new there. I'll give an example of each. So let's say we have 4, 7, and we move. We'll get a y-intercept of 0, 20, something like that. Well, then this absolute value measures distance from 4. And so that's what would be inside the absolute value. And an initial amount of 7 when x is 4. And then it's simply dropping in the second x gets us the absolute value of 0 minus 4. And 0 is 4 units from 4. So we would say positive 4. And we wanted 13 units, and that would be our equation. Nothing new there. That should have sounded familiar. And if we wanted to measure from 4, 7, and an absolute value of 0, let's say 2, then we're actually decreasing. And so that equation would have measured from 4 again. So that would have been still x minus 4. When I drop in a 0, 0 minus, well, I get the initial amount again. 0 minus 4 is the absolute value, negative 4. That's still 4, but they're dropping down. And so there's a negative multiplier. And we'd have a V shape because this is linear. Doesn't have to be linear, but that's all we're going to be working with. So we're just going to get these V-shaped graphs because that's a linear function, and we'll talk about that right now. So if y equals x, there's a critical, oh, I missed that one. There's a critical value here. There we go. And this particular change of signs from negative to positive occurs at 0. And so we started with y equals x, that's this drawing. But what happens when I slap an absolute value? The negatives become positive, and that's what changes things for us. All right. This is actually going over 1 up 1, over 1 up 1. This is actually going down 1 over 1. So we have a kind of a symmetric rate of change, except for, well, one's positive, one's negative, and that's going to hold throughout the types of problems that we're going to be looking at. Now, if I put a 2 in front of this, then whatever this distance is, let's say we have negative 3, not a very good one-to-one scale here, but the absolute value of negative 3 is 3. That's what would happen if we slapped an absolute value on y equals x. But if we doubled it, well, then we wouldn't get 3 out, we'd get 6 out. And hopefully you can see that it's very similar shape, but everything's going up twice as fast. And it doesn't matter whether I put the 2 inside the absolute value symbol. Negative 3 times 2 is negative 6. And if I double that, you know, I'm up here at positive 6. All right, so the multiplier can be either in front or inside the absolute value, which means that if you had something like y equals 2, 3x minus 30 plus 5, well, this is really going up at 6 to 1 on one side and minus 6 to 1 on the other. Okay, and if this is a positive multiplier, we have a V shape up. So we really have a decreasing then increasing situation until we get to the critical value here. That's where it happens. That's where it changes, because 3x minus 30 is actually crossing the x-axis at x equals 10. That's more important than the y-intercept, believe me. So at x equals 10, Numbers before 10, like 9, make what's inside the absolute value negative. Numbers after 10, positive. And so that's where we're going to get this change at x equals 10. Of course, it'll be 10 comma 5 that will be occurring at. That's how you find your vertex. So let me erase this. I'll give you one to graph. And this is slightly more challenging graphs than you've been given thus far. So let's look at y equals the one we just had. 3x minus 30 plus 5. All right, so for 2 points, can you get a correct graph? That's what you'll be facing on each test. And I hope that you can recognize that we're trying to get the absolute value of 0, so that if we put a -1 or a +1 in, you can see where the sign change occurs. So what makes it 0 up here? Well, first off, it's one of these, right? Because it's a positive multiplier. Then we look at what makes it 0. Hopefully you've had enough practice that you can immediately spot that at this stage. And if we make that 0, then 0 times anything is 0, we get a 5. It would be nice if you put the y-intercept in here. I hope everybody knows how to find the y-intercept. Drop into 0. Then we can see that -30 becomes +30, doubled becomes 60, plus 5 is 65. And then you should be able to get that point without doing any more math, really. Change by 10 units, so 20 is going to get us 65 as well. So we are going to up the level of difficulty a little bit. And I fully expect you to be able to handle that. Now, this has basically changed 10 units, sometimes going down, decreasing, then increasing, but my x values changed by 10 here, and they changed by 10 there. And I think we can see 65 to 5. Well, in this case, we're going down 60. So on this side, we're going down at 6 to 1, right? But the magnitude is 6, and on this side, we're going up at 6 to 1, 5 to 65, up 60, 10 to 20, up 10. And you can see the decreasing, increasing signature of the absolute value. All right, so upping the level of difficulty slightly for the second half of the semester, I'm trying to understand that, is certainly an expectation. Now, what does absolute value measure? I think you'll hear commonly, and I probably said it myself over the years, distance from 0, but that's incorrect. Something like this measures distance from 5. If I put a 6 in there, you get a 1 out. What does that 1 represent? 1 unit of change from 5. Put a 6 in, you've gone 1 unit. What about a 4? Well, 4 is also 1 unit from 5. I know we're looking in the negative direction, but you know, it is distance. And this distance is 1 unit, and that distance is 1 unit. So 4 is 1 unit from 5, and 6 is 1 unit from 5. All right, and as soon as we start putting in more challenging statements like 2x minus 7, then we're measuring distance from, I hope you're seeing, 7/2. Okay, so that's one of the skills that you have to have. All right, so now let's solve an equation. Let's take this equation and let's see if we can figure out when would this equation, let's give it a y value. Let's go with 35. What's the easiest way to do that? Well, the easiest way to do that is to see that there's really 2, is this the order I want to do it in? Yeah, well, I'm committed to this point. I'll just do it. So we have a V-shaped graph. We know we have 10, 5. We know that we put a 0 in here and we get 65. We've already figured out that if we put 10 units in the other direction, 20 also gets us 65. And we want to get a height of 35, which is pretty much in between. So y equals 35. And we can see that there are 2 intersections. We want to find those values. Well, the easiest way to do it is over a period of days to understand that as I follow this graph, that's a linear function on the left. And it's a linear function on the right, and we'll use those two branches. What's the one on the left? I know there's an arrow here, but you follow graphs by moving to the right with your hand. And if I move to the right, my hand's coming down, and then it's going up. Well, the easiest way is to just rewrite this as the linear function that is presented, and that's decreasing at a 6-to-1 ratio. Change the absolute value symbol simply to parentheses. Plus 5 equals 35, and learn how to do the following. I wish I'd given I don't like having to see fractional answers here, but take 5 away. Maybe it's not fraction. That's my fault. There's 30, right? So I'm subtracting 5. Dividing by -2 gets me -15. And now that's gone. Adding 30 gets me +15. And dividing by 3 gets me 5. Oh, well, that makes sense. Right? We said that answer would be somewhat between 0 and 10. So I kind of trust that. And so, yes, you're going to have to approximate your solutions before you find them. That's going to be another expectation. That when we look at equations, that we're looking at the intersection of two graphs. And so if that's what we're looking at, then I want you to be able to draw it for me. All right, so now that we have that answer, I'm 5 units to the left, and that's going to be 15 as a shortcut. But how do we find it? Go through the same steps, but we look at the right-hand side of that absolute value, which is going up at that rate. That's how we do the same things, and you'll find that there's a similar pattern here. Okay, the first number is the same as what it was before, but now we're going to get a sign change here at some point. So we're going to divide by 2, which is 15. We're going to add 30, which is 45. Then we're going to divide by 3, which is 15, which is what we said we knew it would be anyway. Okay, so that's going to be something that you're going to have to show us you can do during the second half of the semester, and it's not rocket science. So once again, what's the quickest way to do this to get you 2 answers? It's nice if you understand that it's decreasing. So on this side, -2, 3x minus 30 plus 5 equals 35. And on the other side, 2 parentheses, 3x minus 30 plus 5 equals 35. And solving by showing the 30, -15, add 30, 15, divide by 3, 5. Over here, take 5 away, 30, divide by 2, 15, add 30, 45, divide by 3, 15, and then check your answers. All right, so on a number line, we now have critical numbers, 15 and 5, with respect to this problem. Okay, so we now turn our attention to inequalities. And what if I said that I wasn't looking for when it was equal, but when it was bigger than 35? Bigger than 35. Well, you have to do this to find the critical numbers. And then one more step. Try some numbers. How would you describe those numbers? I'd say that's an interval where my x's, all of them, are bigger than 15. All right, so I'm going to go up to the original equation, and I'm going to look at numbers that are bigger than 15. I'll throw a million in here. 3 times a million minus 30 is an awful big million. I'm going to double it. I'm going to add 5, and I got a feeling that's true. Now, you might have wanted to throw in 16. If you'd thrown 16 in there, you've got 48 minus 30 is 18. 2 times 18 plus 5 is 36 plus 5. Yep, that's bigger than 35. Yeah, but I like a million because I don't have to think as much. So we would say that true. Now, if I put 15, it equals 35. So 15 doesn't work. How about numbers between 5 and 15, like 0? Okay, if we put a 0 in, we get 2 times the absolute value of -30 plus 5. Is that greater than 30? Oh, zero's over here. It's gonna say, no, it's not. So what did I do here? Oh, yeah. So I wanted to put 10 in, right? What makes a 0? So that was stupid on my part. I should have gone down here and looked at this before I said anything. So we put 10 in. That makes a 0. The absolute value of 0 is 0 times 2 is 0 plus 5 is 5. No, false. Numbers less than 5. That's where I should have put the 0 in. And that's the one that gave me this. And that is absolutely true. And what you'll find with the ones that we're working with, this sort of pattern happens every time. The first one's false, the next one's true, and the last one's false. But you watch that materialize. And hopefully you'll gain some understanding as to why. All right, so we're going to do inequalities. And I'll give you one and you can pause. I'll give a negative this time and see if you can go through the things that I just said we will be studying. All right, so I might as well jump right to the chase. Minus 2, x minus 5 plus 6 is less than or greater than. Let's do greater than. Now let's do less than. Now let's do less than or equal to. Less than or equal to, I don't know. Let's go negative 30. That seems like a nice one. All right, so you pause the video. I'm just going to do it. So a negative is increasing, then decreasing. So the first thing I'm going to do is find the critical numbers, and I'm going to do the increasing side, which is the branch 2 parentheses x minus 5 plus 6. Now I'm going to set that equal to negative 30. And then I'll do the decreasing side, which is the minus 2 x minus 5 plus 6 equals negative 30. And I would take a shortcut there, but I don't think you should. So minus 36, minus 18, add 5, minus 13. So that's going to be here on the number line. And then over here, we've got minus 36, positive 18. There's your sign change. All right. And where was I? Oh, dividing. Yep. And now I got to add 523. And I'll do that. And just to check to see if I made a careless error, I'll add these two together and divide by 2. 23 minus 13 is 10. 10 divided by 2 is 5. Oh, yeah, that's what I'm measuring distance from, 5. Very good. Okay. And if I put a 5 here, I can see that that's 18 units of change in the right direction and minus 18 in the left, just to give you an understanding of, measuring that distance. I think it's helpful. All right, so now I'm just going to go true or false, pick a number bigger than 23. I'll pick 100. That might be easier for you to look at. So 100 minus 5, it's still near 100. Minus 200, minus 200. Is that less than minus 30? In other words, I didn't do the whole calculation. I just got a feeling for size. I got a big negative number in here. Absolute value makes it a big positive. Then I'm multiplying by a negative, which makes it big negative again. Here's a big negative smaller than negative 30. Here's negative 30. Here's minus 100. Big negative. I don't know if that's really a true statement. Smaller number than that. So anyway, it's to the left. So this was, I believe, true, which means that's false and that's true. But you go ahead and look at it. And so what do I have? I have something that people have trouble describing. So we're going to use interval notation. Over here is a negative infinity, okay, which is that. And I'm going all the way over here to negative 13. And I'm going to say that negative 13 also works because I said or equal to. So I'm going to use a bracket. And I'm going to also include 23 to positive infinity. And this is called interval notation. Usually takes a day or two to learn how to do that. So we'll just do it over a period of a couple of days. And so here's an interval notation. I'll give you one here with an open circle, and then another one here with a closed circle. All right, so let's put this as the number 2 and the number 5. How would I write this with interval notation? It would be negative infinity to 2 but 2 does not work as a solution to whatever problem we're looking at. But also, that's a U, we can think of it as also. 5 does work, closed circle. Hopefully you've had that practice in your pre-algebra elementary school math classes. I don't trust anything at this stage anymore. And that's interval notation, and nobody has trouble with that. So we'll just learn that as we go along. All right. So that was your little practice there. And then the last thing you have to know, a little bit about domain and range of these, of course, and as a piecewise function. So I'll just show you how to write this as a piecewise function. Sometimes you have to enter graphs into computers in that fashion. And let me get a cleaner board here. All right, so how would I talk about the pieces of this equation here? Let's do 2 again. We don't care, x minus 5 plus 7. Let's call that our function. All right, how could I rewrite that? Well, it's got 2 parts. It's a V shape up, but y values are decreasing, then increasing, so negative slope on this side, positive slope on that side. So y has 2 parts, and they get separated at x equals 5. That's where that change occurs. If I put a 6 in, I get a positive. If I put a 4 in, I get a negative. But the absolute value takes that negative and makes it positive. So that's where it changes at x equals 5. All right, so here's my Alfred Hitchcock. And first side is negative, so I'm going to do minus 2 parentheses x minus 5 plus 7. And we know that happens the negative side when x values are on this side of 5, and you have to communicate that to the reader. Once I get past 5, I'm on the positive slope side, x minus 5 plus 7, but I also have to include 5. It is part of. I either have to put an equal sign here or 1 at the bottom. It doesn't matter. You don't have to do it twice. So your choice. I'll put it in the bottom one. And if I put this into a computer, it graphs exactly the same way. Desmos, you can check it. Right? It's the same graph. And you're going to use these pieces to solve inequalities and equations. All right, so what's the domain and range? Which we haven't been talking about too much, but we want to start talking about them for each equation now that each graph that we look at. So domain is inputs. Inputs are all about what you can use, right? X values, you use X values. Sometimes you can't use an X value in an equation. And right now, for us, that's our logarithms, our square roots, actually even roots, but we'll just stick with square roots for now. And division. You know, there's problems with using numbers like division. You can't divide by 0. Okay, so what can we use here? In this case, you can use anything for this particular type of absolute value. So let's do x minus 4 plus 100, right? What numbers can I plug in there, measuring change from 4? Well, I think we can go forever on a number line to the right, to the left, and put numbers in, find out how far they are from 4. So there's no restriction there. There's no restriction. But this thing has got a bottom, right? It's got a minimum, and the minimum value is 100. This thing is going to mostly kick out positives. The only time it doesn't kick out a positive is when you put a 4 in. Any other number, the absolute value has a distance from 4, which is positive. Distance is positive. So things are going up. And so that's what we call our range. Our range outputs. And the outputs in this graph are all bigger than or equal to 100. And we want to start talking about domain and range so it has more meaning for you by December 15th. Now, I don't think I missed anything. All right, these are the things that we're going to be covering in the second half of the semester. And I hope you have some success with it. The first thing you'll have a chance to have success with is the daily quiz that I'll give you tomorrow. And find out if you watch the video. All right, so let me close this out, and then I'll make another video on quadratics, on linear. I'm going to spell out the entire course and see if you can gain some fluency and learn something.